So today we're not going to spend any time configuring a React environment. We are just going to use the JS Complete Playground. Instead of talking about theoretical topics and abstract examples and foo and bar, I thought we build an application from scratch, something useful. And I picked this game for today's class. So we're going to be building this game. And this game is a simple star game. You get a random number of stars in here, and you get 9 numbers. And you have to pick the sum of the stars. And every time you pick something correct, the random numbers of stars are going to change. So now I have 9. I can pick either 9 or I can pick 8 plus 1, for example. And now I got a new number of stars, which is 9. So I can pick 9 or 7, 5, 6, and 3. So 9. I got 8. What are we doing for 8? 5 and 3. And then we've got 6. Here's 6. We've got 7. Here's 7. And 4, here's 4. And after you're done, you can play again. So this will have us, will expose us to a few very important concepts in React as we progress through this game, right? And there are a lot of variations on how to build this game and a lot of improvements after we're done with this game, just to focus more on these topics and how optimization really matters when you're building a React application. The first version of the game is all the CSS, the HTML and the CSS that I've been using here in the game. Those are not important. So I'm going to actually just copy them and cheat here. And I'll show you how we're going to do that. So I'll copy the whole HTML and the whole CSS. This playground also has a CSS that we can use, but we're not going to be talking about CSS. I just have some ready CSS for us to use. Okay. So here's the HTML. Now, if you refresh the exact same URL that I shared, you'll get this exact HTML and exact CSS. Right? We're not going to be talking about CSS, so the focus is on HTML. So let me just take a look at the HTML and talk about it. This is, of course, it's HTML in React, right? It's all JSX. It's not just HTML. This is a game component, and we are rendering the game component in here, right? So we're rendering a single game component. And also, for simplicity today, we are not going to be writing many components. We'll write 2 components, maybe 3 if we want to go crazy, but it's not about, it's more about the interaction of components than the design of components readability. Of course, it's important that your components are readable, and it's important that your components are not too big, right? But I kind of don't want to focus on that today. We don't have a lot of time to focus on a lot of topics. So my focus is going to be on component interactivity and how to optimize this component interactivity, components messaging, and how to optimize the messaging between 2 components. So maybe we'll just have 2 components just to have focus on that. Okay, so this is very simple HTML. You got the help tag in here. You have a body with 2 divs. You have a left div that hosts the star and the right div that hosts the numbers, and everything is static here, right? Cool. Okay, so the very first step after having this, the designers of this game gave us the HTML, they gave us the CSS, and they said, go make it happen, right? Make everything happen, make everything dynamic, make everything clickable, make the game winnable. So we've got a lot of stuff to do. But here's the thing, take it one step at a time, right? Don't right now start thinking about how the sum of the numbers is going to match the number of stars. Don't do that. Just pick one simple increment, focus on that, get it done, test it, take a break, and then come back with another increment, right? It's easy for you to get overwhelmed that this is a really hard application. Like, how am I gonna figure out that this is wrong and right? How am I gonna figure out? And every time, like, there's something here, we've got, what is 4 and 3? Okay, so when I click 3, the random numbers of stars are gonna redraw. But here's the thing, you can't have 5, for example, stars here. You have to only have either 1, 2, 3, 6, 8, or that's it. So you have 4 choices because the other numbers are used. So there's plenty of complexities in this game. If you want to start thinking about it and overwhelm yourself, don't do that. Focus on one single increment. For example, get rid of this hard-coded static HTML. We're not going to have hard-coded like that, because every time we have to click on a number, we're gonna do some logic, right? So we know that every click here, we know that there's gonna be an on click at some point in the life cycle of this game, right? We know we're gonna be clicking on numbers, which means we can't have this hard-coded logic or repeated logic. We have to have a single way of outputting a number. So instead of all that, that's our first increment. Get rid of all this and make it driven by some kind of loop, because I got to loop 9 times and output this thing 9 times. And I can really simply just use a for loop. I can do a for loop and stick these buttons in an array, and then because React is totally okay with you rendering arrays in here, right? If you put an array in here, it will render it right there. You see it? It rendered the number button. So it's totally okay to have things driven by an array. Let me put another one here and another one. Now we've got 3 buttons in an array, and React is rendering them. So React is very friendly with arrays. So to render 9 buttons, this is the starting point of this game, is just 9 clickable numbers, right? To render 9 of them, all I need to do is have an array of 9 button elements, just like this. And the interesting thing is that if you have an array like this, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and so this will be 9 numbers. You can actually map it into a button element, right? You just map it. This will be, number, and you can just map that into a number element, a button element, right? And guess what? This will work, right? See that? It worked. I just mapped it. Maybe you can put this on 2 lines, which is totally okay. So you see how we started from an array, and we just mapped this array into an array of button HTML elements. React is very friendly of that. And this is actually the declarative way of doing this, is to just map it from an array of other numbers instead of doing an imperative for loop, because the for loop is kind of a little bit imperative, right? You're giving commands to the computer to put things in an array before you actually rendering them, while here you're saying, you know what, give me an array of 9, like render 9 buttons from an array. And of course, if this is bothering you, it's really easy to generate this instead of hard coding it, because maybe later on we're going to render more buttons, not just 9 buttons, right? And there are native ways that you can do this in JavaScript. Generate an array from a number, right? That's the task here, is to generate an array from a certain size. You can do this natively in JavaScript, or you can use, libraries like Lodash. Lodash has one of the functions in Lodash is range, and actually Lodash here is available in the playground as _. So we can use the range function from Lodash and go with 1 to 10. And this will give us an array of 9 numbers. So range from 1 to 10 will give us an array of 9 numbers. Of course, in here, instead of 1, we can just use the number itself. And boom, guess what? First increment done. Think about it. Make sure you've done it right. Test it a few times. But now you can say I made 3% progress, right? Do not distract yourself with other stuff in here while you're focusing on this increment. Cool? Do this exact same thing for the stars, because we don't need to hard code stars like this. We need 9 stars, right? So make it the exact same thing. This is super simple. All we need to do is we kind of like copy the same thing. I just will copy one number in here, 1 star, right? So cut this one, get rid of all the stars, and in here, put curly braces, which insert, dynamic JavaScript. And then we need a new range. This time we can do 9. If we do 9, the range will be from 0 through 8. So I don't really care about the number of stars. Like there's no number on the star. I just care about that I have 9 of them. And then we can map that into, this will give me, star ID. We can call it a star ID. The index of the star can be its ID in this case. And I map it into a div class name star, right? I can map it into that. And that will work as well. Check it out. It works. We've got 9 stars, right? So another increment done. Now, there's one thing that you need to be aware of, we're not using keys in here. So React requires you to use keys. You'll actually, if you're executing this in a fresh environment, you get a warning that you're not using key. So it's easy to just use the start ID as a key here, and in here you can use the number itself as a key. So you always need to pass a unique identifier for a child of a dynamic array every time you use a dynamic array. Every time you do map, within the map, that child has to have a key. So you specify key number. React will only warn you about this because it will actually work without it. If you don't specify key, React will assume that the position of the child is its identifying, is the unique identity identifier. And that could be fine as long as you don't reorder childs. If you start reordering these children, then React will do weird things, right? Now, in our case, we are not really reordering anything, so the positional identity is fine. But just get into the habit of always thinking about the key and passing as a unique value if you can. If you have an ID coming from the database, use that as the key. So a little bit more about this key, right? So if you don't specify a key, right? Let's say we didn't specify a key here for these 9 numbers, right? And so if you don't specify the key, React will just assume the position of this element as the key, right? Which means if I took this 8 and dragged it to replace the 2, React will actually not be aware of this dragging at all. It will see that the second element has changed its content, and now it should be 8. And the 8th element has changed its content, and now it should be no. And the 3rd element didn't change its content; it will stay 3, right? But now doesn't know what to do with 2 because it doesn't have this identity that, oh, we dragged the 8th element because the 8th element didn't have a key. I just dragged an element that does not have an identity in React, and because of that, it will kind of reorder its children and thinking that the content of the children has changed versus something has been reordered. Now, this might be the cause of serious bugs that you're gonna suffer through. So just get in the habit of always having a key when there is a dynamic array like this. If it's not a dynamic array, you don't need to pass a key. You don't need to pass a key here, right? Because there's no dynamic things in here. React will always have this position. It will remember that, oh, we had a game div, and then we had a help div, and then we had a body div, right? This is not gonna change through the life cycle of the application, unless you start putting if statements around these divs, which in some cases you're gonna need to think about keys. But as long as you're not using an array or any conditional or loops, you don't really need to specify a key. You need only to specify a key when there is some kind of dynamic nature to the DOM tree that you're rendering. Now, what's a good next increment for us to focus on for like 3 minutes? And here's the thing, you can come up with at least 20 suggestions from this point what to do next. So there's no shortage of ideas. Pick something that you're comfortable with so you can make progress and commit that. So what should we do next? Well, if you notice that this game, every time you refresh, every time you start a new game, you get a random number of stars, right? Because that's the nature of the game. Every time you click, you get a random number of stars. You don't start with 9 stars, you start with a random number of stars, right? So let's focus on that. Instead of having 9 stars in here, let's have a random number that is between 1 and 9, right? We need a random number between 1 and 9. Now in JavaScript, you can use Lodash for that, by the way, but I'm going to show you the JavaScript way. You can use 1 plus, because you want to start between 1 and 9, 1 plus math. Well, let's come up with, like, if it's math.random, it's easier to start from math.random. So this math.random is between 0 and 0.9999, right? So if you do 9 times that, it will be between 0 and 9.9999, right? So we can floor that, math.floor. We just floor that, math.floor. So now it's between 0 and 8, right? Because I used floor. Now the expression is between 0 and 8. And now I can add 1 to that, right? 1 plus that. Then now we have 1 and 9. So this will give me a random number between 1 and 9, right? Cool. Pure JavaScript. I think there is a Lodash for that. But let's just use this pure JavaScript, right? Now, you can totally just have this whole thing in here and stick it instead of the 9, and things will work. An increment is done. Now I have a random number of stars every time between 1 and, not really, is it? It's working, right? Random number of stars between 1 and 9. But of course, don't do that, right? Why? Well, because now this is kind of hard to read. Like, I have to parse through your code. What are you doing here? And then after I figure out what you're doing here, I'll figure out what you're doing on top of that. So this is becoming a complicated line to read. Instead of that, you should name your variables. You should name this maybe number of stars, or random number of stars if you want. Number of stars. That will make it more readable. I'm just going to name it stars, just to keep things simple. Let's just name it stars. And now stars can happen somewhere, right? We need to know where to initialize the number of stars. Now I can totally initialize it here. I can say, oh, const stars equal inside the game component, right? And this will work fine. Const stars equal 1.math.floor. But here's the thing. This stars, the number of stars, the random number of stars, so stars is the random number of stars, right? This random number of stars will need to change every time I click on a number, right? So the increment that we started with is done, right? We are rendering a random number of stars. Good. So now we're going to need to think about what's next. And what's next is immediately here. We need to think about the nature of these stars, because they are they're gonna change when we click on things. Maybe we need to start designing a state for them, right? Maybe we need to put them on the state because I need to change them. And when they change, I need React to re-render the game, right? So when they change, I need React to re-render the game. So if I want to put them on a state, I can just use the new hooks sting and create a state for the stars. So I can read stars and then set stars. And in here, we'll do useState, right? And the initial value for the stars will be my math expression, right? The initial value for the number of stars will be my math expression. And guess what? This will work as well because I placed it on a state. Yeah? I'm not really changing the state yet, but now this here is thinking ahead, right? I didn't need this right now, but I'm thinking ahead. And every time you're thinking ahead, just keep that in mind. Put a note on it, right? This is a thinking ahead. Okay, I'm going to keep it, but it is a thinking ahead. Because every time you're thinking ahead, you might be doing, you might be making a wrong decision because you don't have all the variables when you start thinking ahead, right? You only have one variable. Stars are going to change and I need to re-render the React DOM. But you really don't have the other variables that contribute to this design decision, right? So it's okay if you want to do it now. That's totally fine. Just label it that you're not sure about it yet, okay? And maybe keep the other version around in case you want to keep it around, right? But I'm just going to assume that we are going to make a good decision here. So I'll just keep that label on it and keep it as the state. So this useState function is a hook, right? So this is a function and it's called a React hook. This is actually React.useState, but it is globally available in here. So this hook, it gives you back two things. The return statement of useState is 2 items, right? Now in JavaScript, you can't really return 2 things from a function. This is why useState returns an array of 2 items. The first item is a reader. So this is the reader of the state. This is the current value of the state. And because we initialize it with that number of stars, it's going to be the random number of stars. And the second item in the array is the updater function. So you get a getter and a setter, right? The getter is just a value, the current value, and the setter can be used to change the value, right? We're not really using set stars, so we can just do that. We're just reading something from the state. This is why I say it's thinking ahead, because I don't need to change it yet. But maybe we can just test it real quick. We put it in like a set timeout. I'm going to put it in a set timeout just to test this setter for you. And in here, let's say after 3 seconds, we can change the number of stars to be, I don't know, let's do 3. So it will render with certain number of stars, and after 3 seconds, it will automatically change to 3, as you can see, right? So this is the set stars function. It's an updater function that we can use to change the number of stars, and when we do, React will react and automatically change the game component in the playground to be to reflect the new value of stars. I think a good increment is to think about if we need to split this one component into other components, right? Now, this is a tough decision to make, and it might be also thinking ahead, right? But I'm going to give you some pointers around how to decide if you need a new component or not. Because right now we're using a single component, and guess what? I can totally implement this whole game with a single component, right? There's nothing preventing me from doing that. I'll just put all the logic in the game component and it's just one single big state manager, right? And it's totally okay. But that will make the game component huge. You need to start thinking about splitting responsibilities, right? Now, I'm not going to do it too much. I'm just going to do it once in here. And I'll give you a very important pointer into where you can identify that a component would be a good decision, right? Here is the pointer. Every time in the UI you have items that share data or behavior, that's a candidate for a component. I'll say that one more time. Every time in your UI, if you have items that share data or behavior, those are good candidates for components. So data is easy. Like if they share data, like the stars share their data because they share their display. How are you displaying the star? I am using a class in the star in here. So this class named star is really data because the CSS is using this to display the star. So that's a good candidate for a component, just one star, right? The other interesting one is when they share behavior. These numbers share behavior. They don't share data. I mean, they might share data, but the more important thing that they're sharing is they share behavior. When I click on each number, the exact same behavior has to happen because I'm going to start thinking, like calculating, was that number a right click or was it a wrong click? Was that number the first click or the last click? Was the game done? Is still playing? Am I going to give them another chance because the sum is not sufficient, right? So every click has some certain logic, and all the numbers share the behavior. Now, they're going to invoke the behavior with a different argument, but it is the exact same behavior. So you get that? Which means this button is a very good candidate for a component because all the buttons share the exact same behavior. Cool? So I'll immediately think about extracting this button. I'm not going to extract the star. I'll leave that as a homework for you. It's easy, right? Just extract the star as a component. But let's extract a button as a component. And now we need to think. So I'll just take this and come back to this place here when I design my button component. So what's a good name for this component? Let's call it number. How about that? Because it's just a number, right? So number. And we make it return the exact same markup that we did, right? Number component. So I've got a game, and the game is the number of stars. Maybe the other component would be star, right? Maybe you have a component for the header help message. Maybe you have a component for the time, remaining time. So these components will make your code more readable. But I'm just going to focus on one component, number. Okay, the first thing you need to see is that this is not going to work even if I do like number in here, because this is how I use it. I would use number, right? This is how I use a component. Things will not work for two reasons. First, number was available in this scope, right? When I was talking about number, this number here was available in this game scope inside the loop. It's not available in here. So I need a way for me to pass this new component the number argument, right? Now this new component is actually kind of like function invocation. It's kind of like doing number in here, right? So when you invoke a function, you can just pass in a number as an argument, right? So in here, I'm just going to pass it in a React component. The equivalent is to just pass number as number here. Number as number. This is how you do it. Now, maybe the name number is not a very good one because now it's confusing. This is a uppercase number. This is a lowercase number. But I'm going to tell you, I'm going to make it work and then improve it. Okay. The other thing is, okay, now that we pass number as an argument, we need to extract it from the props, right? Because a component in React receives an object of props here. So this number here is props.number, right? Props.number. Okay, cool. Also, this key attribute is needed in the immediate child. It's not needed in the number component itself. The number component now is just a presentational component that renders a number in a button. So it doesn't really need a key attribute. What needs a key attribute is this guy, the number, the calling of the number component, this child that will make a number component. That's what need the key attribute. So we move it here. Okay, so test that everything is still working, and it looks like things are fine. We have a number component. Okay, I have an important question for you, and it's an interview question. Imagine yourself in an interview, and we're doing this together, pair programming, and I just made this number component. My question to you is, what did I do wrong? What's something that I did that is extremely wrong in this code? So think about it. You need to identify it right away as a React developer, as a JavaScript developer, really. You need to identify, and you need, maybe even before I ask you in an interview, you should immediately give me a note that I've done something wrong, very wrong. What is it? Number is a native JS type. There you go. That's the big no-no. Why would you do that? We just made a big overriding here of the actual number native JavaScript type. Go to an empty JavaScript execution context and you've got number, right? If I type correctly, there is a number. What is this number? This is a number class. You give it a string and it will change it into a number. And it's a very good one. We use it all the time. So your names have the same scope as JavaScript itself, and you want to be careful about that. Because that might introduce bugs you'll never be able to debug really fast. For example, let's say that this number here is coming as a string instead of an actual number. Let's say that the edges of your stars, like the number of stars, is customizable and it's get passed from the parent, and for some reason the parent is giving you this as a string, right? If you want to do that, it's not going to work, right? There's a big bug now. It's not working because these are numbers and not string. And the solution is to use the number JavaScript class. You say, oh, number on this one, and then number on the other one, right? And if you use number, it should convert it into, you use number on the, I'll just keep one just for the example, right? If you use number, this should work because number is going to convert the string into a number. But guess what? It's not working. Why is it not working? Because number here is no longer the JavaScript number. It is your own number that you put here. It's a React component, and in this particular case, it's doing nothing. It's like having a big no, I don't know. It's concatenating an element with a math.floor. Big problem, right? If you only named this differently, right, your code should work fine. Because, and here's the thing, JavaScript is not going to warn you about reusing something that's already available in the global scope. You just need to know that you have native types, and all the native types, really. And the native types, you can actually get a list of the native types in Node, right? If you go to Node and you just type the Node command and you hit double tab on an empty line like this, just hit double tab in the Node command, you get all the global scope with all the things that are global scope. So don't name your components error or promise or reflect or proxy, right? Or number. Don't name your components in this particular list. So I'm going to go back to one. Here's the thing. If you want to keep your component named number, if you're aware that number is, you're overriding the number class, native JavaScript class, that might be okay, but it's okay for you, right? It's not okay for others who are going to maintain this game in the future. So I would say just don't do it. Just pick another number. And it's usually a good tip to name your components with 2 words instead of 1. Right? If you name your components with 2 words instead of 1, you'll get less of this conflict, right? So maybe just instead of number, name it game number, right? Very simple, game number. And here, instead of game, maybe name it game app, right? Who cares? If it's two names, much better than one, less chance for a conflict, right? Cool? Click. I like that. That's a very good specific increment. Just click on the button, right? And make sure that you can see its value. Very simple increment. You can do it in half a minute, but it is an increment. So to click on a number, let me put this in multiple lines because we're going to be extending this component, right? To click on a number, the best way is to define an on-click handler, right? You define an on-click handler. And also, one other good practice is don't inline the function unless it's a very simple function. Now, this probably is not going to be a very simple function, so don't inline it. Just have another function to handle the click, and usually it's named handle click, right? Because it's a verb, it's a function. So you name it as a verb. Where do you define this function? Right here inside the game number. So handle click would be a function. Let's just console log it. All right, console.log number is clicked. Number is clicked. Now, how can we get the value of the number? Well, it's props.number in here, right? Props.number. So now when I click a number, 4 is clicked, 6 is clicked, it's all working. Cool? My interview question for you is, why did this work? Like, what is the JavaScript concept here that's making this work, right? Because this is a function within a function. And in our little game here, we created 9 functions, and then we created 9 nested functions in those 9 main functions, right? So why is this working? Why is this really getting the value of number? Why is it working? How is it getting the value of number? What is the JavaScript concept in play here that's making me able to access the value of 6, although I've created 18 functions, right? I created 18 functions in here, right? How is every function able to report exactly the value that it needs to report? And the answer is closures, definitely. Closure is in play here. Every function you do, every function you create in here will close over its scope. And the scope is that parent scope. And this scope will have the props object. So the 9 handle click functions that we created, they all have different closures, because they all closed over different scopes. Although it's like probably easy for you to come up with this concept, right, to come up with this solution, it's more important that you know every time you use closures that you know the value of this thing, right? Because it is also might be a source of bugs later on. Because if you forget to refresh the scope of the closure value is going to be stale. And this is especially important with hooks, because hooks depend on closures 100% of the time. So the previous React way, the classes way, it kind of depended on closure a little bit, but it also depended on the instance, right? And the values on the instance. That's the regular, the class way of React. In hooks, the only thing that matters really is closures. So if your closures are not right, if your scopes are not right, and the closures that closed over them are not right, you're going to have some bugs. So it's important that you start understanding closures and you start identifying when closure is in play, like in here, right? All right, let's start thinking about clicking the logic that we need to when we click on those buttons, right? So the logic that we need when we click on those buttons is basically, when we click on a button, we need to color it differently. The first thing in this game, when you click on any button, even if it's not like, if it's neither right or wrong, we'll just color it differently to say that this number is used. Pick one more to get to the sum. You got 3, you need 4. And if you click 4, it will be marked as used, right? It can also be marked as wrong right away. If you click on a number and it's greater than the number of stars, it should be marked wrong. there's a lot of logic here. And this logic is not really React. This logic is all JavaScript. So I'll try to go over the logic real quick. But I want to show you, I want to tell you how React can make this testing of the logic a lot easier, because the logic itself doesn't matter. What matters, I mean, it matters, but what matters today is for you to understand how React enables you to write programs quickly by maybe skipping the logic altogether, because you can fake the logic, right? So instead of thinking about the logic, instead of thinking about, summation and comparison with summations, think about the UI, because React is a function of your UI, right? It's not a function of your logic. React is a function of your UI. And you need to think about that. The logic, maybe go get help with the logic, because it's just JavaScript logic, mathematical logic. It's easy to figure it out. It needs a mathematical scientist, maybe, right, in some logic. It doesn't matter. You'll figure out the logic, but your task as a React developer is to design the elements of the UI right, not the logic. You might have bugs in the logic and no bugs in your React application. That's a win as a React developer, because the logic is separate. Now, if you're the same person responsible for the UI and the logic, sure, we're going to have to focus a little bit on the logic as well. But let's now start by thinking about the UI. Cool? You get that distinction between, mathematical logic and UI logic, two different things. Okay, so the UI logic is every time we click on a number, that click has to re-render the UI. That's the biggest point. Every time we click on a number, that click will need to re-render the UI, because I have to render that number with a different color. Regardless of the color, blue, red, green, doesn't matter. I have to re-render the number with a different color, which means I have to re-render that component that I clicked on, right? So I need to trigger a re-render. And what does that mean in React world? State. Every time you need to trigger a re-render, that means you have to place something somewhere in a state, in an internal state for a React component. So, okay, we've got that far. We need to put something on the state every time we click a number. Next question, what do we put on the state and where do we put it? In which component, right? Two important questions, what to put on the state and where. To simplify things, I don't think we need to make this game number component stateful at all. We can just make this game number component a complete presentational one and make the game app a stateful stateful component instead. We can definitely put a little bit of state on the game number, but I want to show you how managing the state in one place has its benefits. So we're just going to manage the state in the game component. So we're going to put something on the state right here in the game component. So the next question is what to put on the state. And there are two concepts at play here. The first concept is you using numbers. So when you use a number, right, that's basically the number has been green and you can't reuse it again, right? That's a used number. I'm going to call it used number. Don't call it green number, because you might change the UI later on. This is a used number. The other concept is kind of like the selected number. This is, or like if you unselect this number and select a different number. Now this is a selected number. It's not used yet. It's just selected. And you might select other numbers. And if you get to a state where two or more selected numbers are good, you mark them used, right? So you've got the concept of used numbers, you have the concept of selected numbers, and you have the concept of wrong numbers, right? Three different things: selected, used, wrong. Cool, you get that? So now your question is, what do we put on the state? We identified three things. We identified used, we identified selected, and we identified wrong. Used, selected, and wrong. Okay, so what to put on the state? And you can totally put all three of them on the state. You can manage three arrays on the state: one array for used numbers, one array for selected numbers, the temporary state before they were used, and one array for wrong numbers. If you select something and it was wrong, just put it in an array of wrong numbers and you'll have the UI change that eventually. But here's the other major thing about designing state. Very important concept about designing state. Don't put on the state anything that can be computed from other elements on the state. I'll say that one more time. Don't put on the state anything that can be computed from other elements that you have in your component. So can we compute one of these based on the others? Like if I said, let's just put used and selected, can I compute wrong from that? And the answer is kind of not clear yet because we don't have any, summation of stars. But if you think about it, this wrong is kind of depending on selected. So you can't be wrong and not selected. You have to be selected to be wrong, right? So it depends on selected. This is the first thing. The other thing it depends on is the sum, the length of the stars array, the number of stars basically. It depends on this other state, stars, right? So we can totally compute wrong from selected and stars. Basically, the condition for wrong is, and this is thinking ahead, but just so you know, if selected and greater than stars, it makes it wrong, right? Kind of like this is it's an easy logic for you to figure out if the selected number is wrong. So this is when you realize that you don't need to place wrong on the state. You just place used and selected, right? And keep thinking, maybe you don't need to place selected, but I'm just gonna place used and selected because I kind of know the easiest way to do this is just to do used and selected. All right, so now we have two choices to place used and selected on the state. We can come up with a state object instead of a state scalar value, because what we have here is a scalar value of 1 through 9, right? Just a scalar value. You don't have to have a scalar value. Your state could be an object and you could put things in the object. But I'm going to show you the non-object way first. So the non-object way, you can just come up with another scalar value for used. Let's call it used numbers, or maybe used numbers array, and you get set used numbers, right? And you do use state, and you need an initial value. It's an array. I'm going to place them in an array because you might use multiple numbers. And you would do the same for selected numbers. So selected numbers is another array. Selected numbers, let's call it selected numbers, right? And set selected numbers. And it will also start with an empty array, right? So this is me designing the state. So again, there's nothing wrong in having multiple state objects in a single React function components. You can totally do that. You can have multiple states. And React will figure it out magically, and it will make it work. So now I have this, and the stars are fine. Every time I get random number of stars, and life is good. Okay, so now that I designed what needed to be placed on the state, I have two tasks ahead of me. So this was task 0. Design what to place on the state, where to place it on the state. This is your primary task as a designer of React component. After you design what to place on the state and give them proper names and everything, you have two important tasks. One task is about making the UI, changing the UI description to reflect this new elements that you put on the state. That's task number 1. Changing the UI description, which is basically your return functions, your virtual DOM, right? This here is a virtual DOM. It's a UI description. It's not a DOM. It's a bunch of React elements that describe your vision for this DOM, right? React will take that to the DOM. So your first task for used numbers and selected numbers is to change these UI descriptions to honor this new element that you put on a state. Now, if I have a used number, the UI should behave differently. So keep in mind that your UI is just a function of your state. Your UI is a function of your data, of your state, right? So if you introduce a new element on your data and state, you need to reflect this in the UI. You need to change the description of UI to honor this new element, if there is a used number. That's task number 1. And task number 2 is the behavior part of it, right? So task 1 is data, task 2 is behavior. Once your UI is completely honoring the new elements of the state, then you start thinking about transacting on the new element that you just put on the state, right? You don't think about transacting on this new element until the UI is ready to describe a state, to describe a snapshot of this element, right? So usually when you implement this, people jump into the transactions and handling the onClick event handler and making it change the used numbers, right? But there's actually a lot easier way to just start with the task 1, making the UI honor this new state element that we just introduced. We can just fake some data here. We can say, let's select number 2 and 7. Fake it until you make it. And let's use number, I don't know, 5. Let's just use number 5. This is fake, so maybe put it to do, remove it, remove fake data so that you don't forget. But if you put fake data like this, right, you can totally do task 1 completely on its own without worrying about transacting on this state element, right? How to change this state element. I don't need to do that yet. I need to make the UI honor the new element that I put on the state. And this is true for every state element that you introduce. Every state element you introduce will have reflection in your UI, and it will have some kind of behavior later on. So let's focus on the reflection. Okay, so if the number is used, I need to display it blue, right? That was the design. If the number is used, there. If the number is used, I need to display it blue. If it's selected, if it's used, I need to display it green. If it's selected, I need to display it blue, right? Let's actually have some kind of, colors dictionary. Let's call it colors. So colors, and start thinking about it, because this is something that you customize later on. So it's not part of your logic, right? The mapping between the state of a number and its color, it's not part of your logic. This is customizable, might be passed down from parents or other applications. So it's always a good idea to have a dictionary for that, so that you don't hard code values. You don't hard code the values of the colors in your whole application. You just use a dictionary, right? What was it? Used. So we've got used. We're gonna give it a color, and we've got selected. We're gonna give it a color, right? That's what and we've got wrong too. That's part of the dictionary, wrong. So I think the colors I used is, let me cheat. Let me give you the colors array I used. Yeah, so I used light green for used, and then for selected, it is deep sky, deep sky blue, and for wrong, it is light coral. So not really red and green, just a little bit more easy on the eyes. Okay. Here's my colors dictionary. How do I use it? A bunch of if statements, right? What do you think? So we need to basically compute the style of each number, right? We need to compute the style for each game number based on this state, right? Based on this state. I need to compute the style of each number. Now, I'm going to use inline styles here. I'm not going to introduce any extra CSS because these styles are conditional, right? It's blue if it's selected, so there's a condition involved with these styles. I'm just going to use inline styles and actually have the condition in there. What I want you to focus on is, do we pass, because the game number is the one that is going to style itself, right? We're going to start passing this game number new information for it to be able to style itself. Right? You get that. We're going to pass it new information for it to be able to style itself. So you might start thinking that because it needs data on whether the number is used or selected, maybe we just pass it the used numbers array, because the used numbers array is part of, this function, used numbers, right? And maybe the selected numbers array is part of this as well. So you can do selected as number. Now it has access to used numbers and selected numbers. The game number component can totally do the logic of should the number be displayed as used or selected, right? Wrong. And you should totally stop me there if I'm doing this in an interview and tell me you're actually passing way too much information for this game number component. It doesn't really need the whole array of used numbers or the whole array of selected numbers. What does it need? It needs to know if a single number is selected or used, right? It doesn't need the whole array. It just needs to know, is an individual game number selected or used? So instead of passing this state into the game number and having logic inside the game number about whether a number is selected or used, we should really have the logic of that here instead. Because if you put the logic here, then you don't need to pass to a component more data than it needs to in order to render itself. If you pass, there's nothing, it will work if you do that as well. If you pass the whole array of data down to the game number component, things will still work, but you are really passing way too much props than the game number component needs to render itself. And that's kind of a no-no, because if you pass more props than what the component needs, you're going to be doing wasteful renders, because React really depends on these props, right? If the props change or not is an important question in the React component. Do I need to re-render myself? So if you can minimize the number of props you pass and pass exact data to the component, things will be much better. So that's what we should do. Let's make this into an official function, right? It was just a single liner. And let's return this game component. And instead of this, let's think about it. Instead of two used numbers and selected numbers, right? Let's think about it. This will not work, but it will highlight it differently. Instead of all the used numbers, we can maybe pass is the current number used, right? Boolean, flag, true or false. Is the current number selected? Is the current number wrong? If I pass that, if I do the computation here, and pass just true or false, then I will be directly passing exact information for this component to render itself, because the style logic belongs to the game component, but the selection logic and the use logic belongs to the parent component, so that I don't pass extra information to the game component. Okay, so this logic is math, so don't focus on that. I'll just type it in here. The logic of whether a number is used or not is simple math. Is used is, what do we have? We have the used numbers is an array, and if the index of number here is greater than or equal to 0, then the number is used. Because I have used numbers, right? It's an array of numbers here, and I am comparing this particular number to that array of number. If this number exists, this means exist, right? If this number exists in the used numbers array, then it is used, and it should be marked as used. If same thing for selected, right? The is selected is the exact same logic. The number is selected if it exists in the selected numbers array, right? If it exists in the selected numbers array, is used and is selected. Okay, typo, number. There we go. And now we can just pass is used and is selected. Is used and is selected. Cool? Instead of all that. This is much better. And again, you need to be able to explain why is it better. Now, I'm not passing this component more information than it needs to render itself. I'm just passing the exact information that this component needs to render itself, and that's a much better. All right, here's the thing. I've wrote way too much code without testing, right? So before I go into colors, I should really test this logic. How do I do that? And look at that, it's not even compiling, right? So let's figure out what is wrong here. Usually the error here is helpful. So on line 33, it is expecting, the lines are kind of a little bit messed up. It's not exact here, but yeah, in here, index of number is greater than or equal is that way in JavaScript. If you flip it, JavaScript will think it's an error function. So greater than or equal. All right, cool. So it is rendering, that's my first test. But the other test is, maybe I can just log the props. I can just console.log the props and test that is used and is getting correctly passed to the component. So if I console log the props, I get all of this true. Is used true, see that? And is selected true here because of my fake data. So it is working. I have two used numbers and I have one selected numbers. So these computations are working. Tests are done. Move on. Now I have is used and is selected, right? What can I do to make these well, I need logic for the style, right? So let's think about having a function here to compute the style of a number. Let's call it number style. And again, this might be a wrong decision, right? I just it's always the way that you just go with what you know and then reflect on your code. Just don't be attached to your code, right? Because in a minute, I'm going to destroy all this, and I'm going to tell you why, right? Just don't be attached to your code. Just go with what you know and reflect on that. Okay, number style. we need to change basically the background of this button. The background is gray here, right? And you can test that in Chrome. There is a background and we can change it and the button will change color, right? So we need to change the background of the button. So I'm going to make this style part of the button component. So in here, I'm going to do style equal, number style and call it number style. So I just need to return an object. I need to return an object basically because that's the style attribute in React. So by default, the number doesn't have styles. But if the number is used, so if props.is used, because that's what we did, right? Props.is used. If the number is used, maybe return a different object here with a different background. So background is, if it's used, it's light green, right? So we can just do colors.used, right? Because that's the dictionary. And if the number is selected, then return background with color.selected. How about that, right? Very simple if logic. The simplest way you can implement this logic is with if statements because it is an if statement. If it is used, if it is selected. So just how you think about it. But I get that this is a little bit imperative. I'm going to tell you why this is imperative, but it is the simplest. And here's the thing. We should probably move on and do something more important after we get this tested. Okay, const, we need an equal here. Number style is a function. It doesn't matter. And oh man, I deleted it. And there you go. Look at that. The selected one worked, right? The used worked, but not the selected. Is selected is not working. You've got a problem. Background. What is the problem? The problem is selected. There's a typo. The typo is in here. Selected. Okay, cool. Check it out. Numbers used and selected are working. Did you see how I totally focused on task 1 and did not at all think about transacting on this state? And I can mark task 1 as done, right? It might be ugly, but it's done. It is working. It is bug-free so far, according to the tests that I designed before even starting on this task 1. So far, so good. Let's dive into task 2 before starting analyzing the code and thinking about the code. Because as you make more choices, you'll get into questioning the code at certain points in the life cycle of this game component. So let's move on and design the transaction. Now we can get rid of fake data, right? Because I know fake data work. Now I'm ready to transact on these state elements. Can I get performance issues having multiple states? And the answer is not a big deal issue, right? React is very smart. All of these use states are in React's memory and they're deep in React's algorithm. So React is doing very smart things to manage your state. You will not have any penalty to the browser itself, right? So there's no, managing multiple states is not gonna make React write to the browser's DOM multiple times. That's not the case. All of these set state calls, they're batched for performance with the browser. So I would say, no, there's no penalty. Just don't go crazy and have like 20 state elements. Maybe at some point the component is too big or your state belongs to another state manager, not just flat like. So I think it's time for us to go into the dark task of clicking on a number and reflecting and transacting on a state. Because here's the thing, here's the very good news, here's the value of React. Now that I made the UI honor the state elements, I don't really change the UI. Zero changes in the UI. I already made my UI honor the state elements. Now the next task 2 for this important increment is that you focus on transacting on your state, right? You don't transact in the UI anymore. You focus on transacting on the state because React will transact on the UI on your behalf. You just give React a description and we just give React a description. We said, if the number is used, color it this way. If it's selected, color it this way. And I'm done. I don't transact on the UI. I don't go to the UI and say, pick an element, make it green. No, I transact on my state. I transact on my data elements, right? And I need to do that with some new logic. This logic is basically data transaction logic, right? Because I need to figure out the game logic. Now there's a bit of logic in the game itself, but this logic belongs to, the logic I'm going to do is set used numbers, right? And change used numbers to have some data and maybe set selected numbers. I need to use these guys now, right? That's the set. I need to set selected numbers and set used numbers. This is the logic. And it's easy. When you click a number, it is selected for sure. But if the number is the right sum, so I'm going to start having another if statement. If the number is the right sum, then the number is used, right? And if it's used, it's not selected. It can either be selected or used, which is important. This brings up a bigger question. So just think about this logic a little bit. This logic will use stars. So this logic needs the value of stars because it will compare the number of stars. It will need, that's it. It will just need the value of stars, and it will update what? It will set used numbers of stars and set selected numbers of stars, and that will update. It will also actually use set star, because if you think about it, if the selection is right, I need to draw a new number of stars, right? So it will actually use all three state elements, right? It needs to use selected numbers here, because if you're just selecting numbers, then you're not ready to make a decision. So you need to use selected numbers. So if you analyze this a little bit more, you realize that all these states really belong in the same kind of logic container, right? Because to make a single decision about a number click, I need to ask the stars how many you have, inspect the selected numbers array and see how many, what's in there. And then when I'm done with my logic, I need to change the used numbers, the selected numbers, and the stars. And sometimes I don't need to change all of them, but in some cases, I will need to change all of them, right? In some cases, one click, like in here, we have 8 stars, right? If I click 8, if I click 1, it's just selected number, right? But if I click 8, it is used number, and it's also a new number of stars, right? So you see this relation between the state elements that we have? They're not really independent. They depend on each other. This means that we should reevaluate our decision to have individual states, because these states depend on each other, and this next function that we're going to write needs to read from all of them and write to all of them. And we can do that, we can do that, keeping them flat like this, right? But it would be much easier if instead of all this, we introduced a single state element, and that element is an object, so that we can work on a single state element. So I don't need to have it as a scalar value. I don't need to have it as a number. I can have it as an object. So this is what I'm going to do. So my useState, so I'm going to have a new element here, and I'm going to call it just state and set state, right? And in here, this new state is going to be an object, or a map. You can use a map if you want to, an object. And in that object, I can have stars, I can have used numbers, I can have selected numbers, I can add more stuff if I need to, but it's an object of things, right? And in here, you use the initial values. This is all the initial value, right? So we can copy the initial values for the stars, the initial value for the used numbers, the initial value for the selected numbers, right? Again, I am coming up with this decision because I just realized that I need all these elements together to do the computation on whether the number should go selected or used, right? So when you do such decisions, right, before you go, don't pause. When you do a decision like this, pause. Don't go further in your code. Change your existing code to work with this new decision, and that change is its own entity, its own commit, right? Because I've made a decision now. I broke the code. No, the code is no longer working, right? Probably. And I broke the code. So before you introduce any further code, change the existing code to reflect on this change, test things and make sure all the tests are passing, and then come back, commit that, its own commit, and then come back and further this code with more logic. Okay, so everywhere we used stars, now it's not stars anymore. It is state.stars, right? Because it's part of an object called state. And what about here? Same thing here. It's not used numbers anymore. It is state.used numbers, and it is state.selected numbers, because now it's an object of state. You can name the object anything. It doesn't have to be state, but state is probably a descriptive name. All right, cool. So is it still working? Yes. Maybe even test it with numbers, right? So to make sure it is actually working. Yes. All right, so we commit that. We can now clean up. So what we had before is equivalent to this. When the state will be purged from memory when we use setState. Every time React re-render the function component, it will get rid of the old state and create new. The first time you render the game component, let's take this example as is now. The first time React render the game component, it will create this initial state object, right? It will create this initial state object, and keep that in memory. The next time, the second time, the game app component get rendered, the argument is ignored because the argument is just the initial state. So React will ignore the argument and it will just give you the current state. And it will keep doing that until the game app component is gone, right? When the game app component is unmounted, React will release the state and it will be garbage collected. All right, so one other UI change that I forgot is the wrong state. We didn't do the wrong numbers, right? We did selected, and we didn't do wrong numbers. So this should actually happen before the logic to transact on the state is to display if the number is wrong, right? Like if you have a number of stars that is maybe, I don't know, random numbers, but let's say I have 4 as selected, right? Every time you have a number selected, that number might be either selected or wrong. When you select the number could be either selected or wrong or used. Now, we've got used and selected, but we didn't get wrong. So how do you describe wrong? And because it is something that we decided that we can compute it, right? Or computable, right? I can compute it. I can totally put it right here in a constant. I can say, current selection is wrong, or let's call it selection is wrong. And I can compute it here. I don't need to place it on the state. So things that are computable, you can just place them as variables inside your component, just like that. So when is the selection wrong? The selection is wrong when if the selected numbers are more than what we have in the stars, right? If we have more in the selected numbers than what we have in the stars. And that means we need to sum the selected numbers. If I have, 4 and 2, if 6 is more than the current stars, then the selection is wrong. But if 6 is less than the current stars, then they're just selected. Selection is not wrong. So basically, I need to sum this selected numbers array and compare it to the numbers of stars. And Lodash has a function for that. So we can use Lodash.sum the selected numbers array, which is state.selected numbers, and compare that with state.stars. If the sum of the selected numbers that we currently have on the state is larger than the number of stars that you have, that selection is wrong, right? And if the selection is wrong, we need to change this logic. If the selection is wrong, we need to change this logic, right? Now, same thing applies here. I could pass selection is wrong to this component and do something like, oh, selection is wrong, and then use selection is wrong in the logic to display, the red color, right? This is totally possible, right? But it is also the same problem. You're really passing more information to the component than it needs to. The component needs to know if the game number component needs to know if itself is a wrong selection. It doesn't need to know if its neighbor is also a wrong selection, right? So the number 4 here, when we have 4 and 2, the number 4 needs to know, am I wrong according to the current number of stars? It doesn't really need to know that the 2 is wrong and the 1 is not wrong, or the 3 is wrong, or the 5 is not wrong. It only cares about its own self, right? So instead of selection is wrong, we do is wrong, right? And it's the same thing here. Is wrong is selection is wrong, selection is wrong. Hold on, selection is wrong, and how do we do that? So is wrong is selection is wrong, and the component is selected. There you go. If the selection is wrong and the component is selected, that means that number component is wrong, but doesn't care about the others. So you get this logic here. Selection is wrong and the component is selected. Okay, so if the component is wrong, what do? If the component is wrong, what we do? Well, we can just add another logic here in our if statement and do something like, all right, if is wrong, then colors is wrong. Except that, is wrong, then color is wrong. Did I not do that? Oh. So, if the color is wrong, right, then output it as wrong. But here's the thing. The order now matters in these if statements, right? Because you might have two things together. Like the number could be is selected and is wrong. So the order matters. If it's selected and wrong, do you want to output it as selected or as wrong? We actually want to output it as wrong. So we need this statement before the is selected statement, and that order matters. If it's wrong, output it wrong. But if it's selected but not wrong, just make it selected, right? So there you go. 4 and 2 are wrong because we have one number of stars. If we keep testing, now that we have 8 numbers of stars, they're not wrong yet. They're just selected. Cool? You get that? All right. UI is kind of complete in terms of its honoring of these new state elements that we just introduced. Now it's the time to do this big logic of, okay, what should we really do when we click on a number? Now, this is going to be a massive logic, but what I want you to focus on is, again, the React concepts. So let's back to no fake data. I sometimes forget the fake data. And the thing is, the first React concept that you need to understand here is that this logic of computing whether a number should be marked as used or selected, this is basically what we're doing. Should number be in selected or in used, right? That is basically the logic that we need, because if it's just in selected, it's just selected, right? If it's in used, different story. And based on these two arrays, we're going to display the number differently, right? So it's a kind of simple logic, right? But what I want you to understand here as a React concept, this logic has to be on this level. It has to be under the game app component. Why? Because it works with this state object. Because it reads and writes this state object. So it needs access to the reader and to the writer of the state object, which means that it needs to close over these two guys, right? It has to be in the game app component. It cannot be anywhere else. You cannot put it in the number component. It has to do. This is the closures again in action, right? It needs to be on this level. The other concept is we need to give it a name. This is going to be a function that close over, so we need to give it a name. What's a good name for this? Maybe you can like decide what to do with clicked number. Yeah, naming is hard, right? Or we can simply say, well, this is what we're going to do on each number click. So I'm going to call it on number click. This is what we're going to do on every number click. So this is kind of like UI driven name. And I am definitely not very good at naming, so let's just go with on number click. Okay, so this on number click, another thing that we're going to do is the first increment is to wire it correctly, right? So we know that it will receive a number because this is something that the number button, the game number component is going to trigger as a behavior, right? This is the shared behavior that I was talking about. This is the reason we made the game number component, right? So maybe we test it here. Just log, not this log, just console.log, on number click and the number that was clicked, and test that. Make that work before you actually put in the logic, right? Make that work before you actually put in the logic. All right. So here's where we go into another one of those React concepts, right? How do we make the number component invoke a behavior on the parent component? And the answer is data flow. Okay, let's do it. The question is about UI logic and application logic. Right, we are mixing UI logic with application logic. Although we're kind of like smart about it, we're doing this first and then the other next. We're still mixing UI logic with application logic. And while it's going to work, it's not really maintainable. If you want to make this a little bit more maintainable, you got to start splitting logic that belongs to the same scope into its own container, right? That's actually why libraries like Redux are popular, or were popular, right? Because Redux allow you to split your application logic into its own container called Redux, right? And then your UI logic is React. So your React becomes just your own UI logic, and then everything application logic will be in Redux land. Now, the way the React API is changing today, your application logic will belong in hooks, right? More or less. Instead, if you're not going to use Redux, you can still use Redux and have all the application logic in Redux. But if you don't want to use Redux, there are some things that you can do. You can improve your hooks. You can expand your hooks, right? So maybe selection is wrong. The application logic should also go inside the hook somehow. And this is where we start thinking about custom hooks, right? Custom hooks is your own hooks, not the React hooks, that you do and make all the application logic inside of them. And then you just hand the UI a getter, just a single element, a current value. And the UI will render itself based on that value. If you have top level information, like who is logged into the application, right? This is a top level information, who is logged in. And you need to access this top level information deep in the tree. Imagine that you have a tree, you know, the DOM tree is usually a big one, right? If you inspect any DOM tree, there is a big tree of nested components, right? And this nesting goes deep down. This is the exact same story in a React application. You will nest your components. Right now, we only have one level of nesting. We just nested a game number component under a game app component. But in reality, your components are going to have 7 and 8 levels of nesting, and maybe even more. So what if child number 7 needed to access the user's profile information from the top parent component, from the component that actually subscribed to it and got it from the server, right? What if child number 7 needed to access that? How will it do that? If you're not using some global mechanism for it to hook into this state directly, then you will need to pass it down all the intermediate children, right? All the children from parent number 1 to child number 7, they have to pass this information, flow this data, because it's a one-way flow of data, right? Parent can flow to child. So you're going to have to pass it. 6 components needs to pass it down, and they really don't care about it. Only component number 7 cared about it, right? So it's a bit too much. So the solution is global mechanism for reading this data. But you can't just have it global. You can't just have it purely global, because that would leak into the global scope. Also, maybe you render the exact same React application twice, right? So you can't have it global and have multiple React applications reading from this global thing. So the answer is use a kind of like a semi-global thing. It's not global, but it is global for your own application. It is global for the game app application. And this semi-global thing is called context in React. You would use the context API to define a semi-global thing that's only global to your own top-level component. And now all the children of that component will have access to it, can have access to it if they choose to. You don't have to make it, you don't have to read it. If you don't need it, don't read it. But it is a semi-global thing that's available for all the components. If the game app component is the provider of that semi-global thing, then all the children of the game app component will have access to that thing. So now let's think about this logic some more. We wanted to test this logic, right? So to test this logic, we need this handle click here. This handle click here needs to invoke now a function on the parent component, right? We don't need this line anymore. We need the parent to invoke its onNumberClick function, right? Here's the thing. A child cannot really tell a parent anything in React, right? Because of one-way flow of data. The data only flows from parents to children, right? Keep that in mind. You cannot flow anything from children to parents, right? There's no mechanism in React for a child to tell the parent anything, except just like you flow data, in here we're flowing data, right? Just like you flow data, you can also flow down behavior. You can flow down a function, and this function, so this could be like totally a new function. You flow down a function. If you flow down a function, then the child, from the point of view of the child, it's just another property, right? And the child can just invoke this property, right? If it's named action, exactly an action, from the point of view of the game number component, this action is just a prob. So it will access it, probs.action, right? And this prob, this particular prob, is a special one because it's not just data. It is behavior. It is a function, which means the child can invoke it. Okay, so keep that in mind. We're only flowing down things, either data or behavior. But by flowing down behavior, the child can invoke predefined actions, right? Predefined actions in the parent, which means it's kind of like giving a child access to a function in the parent component, or kind of maybe give it the privilege or the permission to access something in the parent component. So that's exactly what we're going to do. We're going to pass down the whole onNumberClick function as an action for the game number component. We just pass the onNumberClick itself, a reference to it. Not, we're not invoking it. We're just passing it as a reference. Now, from the point of view of the game number component, we could also name it onNumberClick, but a better name would be just onClick. What to do onClick, or onClick action. You can name it whatever you want. I'm just going to name it onClick. So now the parent is dictating what a game number component should do on click. It's no longer the responsibility of the game number component. It's now the parent is dictating what a number should do on click. So when I click, my handle click here as a game number component will be on click, the prob, the new prob that was just passed to me. Probs.onClick. This is a new prob that was just passed to me, and I need to invoke it because it's a behavior, and I also need to invoke it with my own number. That's how I test it, with my own number, right? So in here, this component is just invoking behavior predefined by the parent component, right? And let's test it. onNumberClick, life is good. So this concept here is called flowing down behavior. Flowing down behavior, not just data, right? And the child gets to invoke this behavior, and it gets to invoke it with custom data. So it is kind of like working around the fact that a child cannot communicate any data to the parent. Now, by invoking a certain behavior with custom arguments, we're kind of communicating that you should now do the logic for number 7 or number 4. All right, so what is this logic to be done? Again, this is the question. This is the big question that we need. Should the number be put in selected or in used? Another question that's important here: should we redraw stars, right? Because some numbers, some clicks are going to actually redraw stars. If the number is correct, we need to do that. So it's important to think like in abstract what a function needs to do. All right, so let's start simple, right? We've got number, and we're going to do some logic in it. We need to read the state, right? Read the state in here. Before we do any computation, we need to read the state because this logic requires stars and selected numbers. So we need to read them from the state. Now, here's the thing. After we read the state, we need to set the state, change the state, right? So we need to read the state and change the state, right? And in here will be like logic, plenty of logic. So we need to read the state, do some logic, and then change the state. You get that? Cool. So let's do that. I'm going to come back to this note here that what I'm going to do next is not the ideal thing. But that's basically what we're going to do. We're going to read the state, do some logic, and change the state. Okay, so how do we read the state? Well, in here, it is, it's just stars and selected numbers. So I can start. Actually, let's just do it right. Let me tell you why this is a problem, right? Let me tell you why this is a problem. Every time you read the state and then change the state after that based on your first reading of the state, you're kind of doing a race condition because the state is async. Any state updater, all the state updater functions are async. Now, why are they async? Because React need to batch things together for performance reasons. So every time you do set state, Every time you're going to do set state, that's an asynchronous call. It's not synchronous, right? Which means it's going to be removed from the normal flow of the application and put on the next tick of the event loop. That's the simplest explanation for it. It's asynchronous. It's not going to happen right away, right? And every time you have asynchronous and you're reading and writing to the state, that's a chance for you to run into some race conditions. If you need to read the state and then change the state, instead of set state, instead of reading the state like this and then setting the state in two separate steps, you should set the state with an updater function, just like this. Set the state with an updater function, and this will give you access to the previous state right before it's executed. So in here, you read the previous state, and then you return the new state. You return the new state. This is the new state. And this way, you will not run into race conditions. This is only needed if you need, so you don't read the state in here. You invoke a set state call, give it a function instead of an object, and that function is going to receive the previous state, and this function will be atomic. It will not run into race conditions because it will read the state immediately before it executes itself. All right, so we call this signature of set state an updater function signature, and this applies to anything. Even if your state is not an object, even if your state is just a single value, every updater function accepts this other signature of a function where you can read the state inside the function and return the new state that you want to read. Cool? All right, so let's do it right. This is what we need. We need to use the updater function for sure. This is how we read the state. Put the logic. Now the logic can be here, right? The logic can be here, and the reading of the state is here. And the writing of the state is this last one, is the writing of the state. This is the new state. Cool? All right, so let's read the state. This is how we read the state. We're going to take it out of the previous state. So we can use destructuring here. Well, we can take all of them. Let's take the stars, the used numbers, and the selected numbers out of the previous state. This is how we read the state. Cool? And I'm going to use all of them. Maybe not use numbers, but maybe standard way is better. All right, so every time you click, the simplest way to think about this is every time you click, let's just put the number in the selected numbers because, chances are like 90% of the cases, it will just be selected. So I need to put the number in the selected numbers. How do we do that? Put new number in selected numbers. So maybe the easiest way is in here, since I have variables in here local to this function, the updater function, when we're done, we just return the exact same variables. So stars, used numbers, and selected numbers. And by doing that, I get to modify them here based on logic. So the new selected numbers would be, we need to append, right? We need to do like the existing selected numbers dot push. Not dot push, like dot concat, right? Because dot push doesn't return. Concat the number, right? This is one way of doing it. The better way of doing it is selected numbers equal, spread the existing selected numbers and then add the new number. This is a better syntax. I think it's a more readable syntax than concat. But both ways are valid. All right. So we've selected the numbers. We put the new number in selected numbers. Now what do? Well, we kind of need to figure out the sum of selected numbers. If the sum of all the selected numbers, because I'm selecting one number after the other. Right now I have an array of selected numbers, so I need to figure out the sum of selected numbers and kind of compare it to the stars, right? Because if the sum of selected numbers equal to the number of stars, then we have a correct pick. Right? Then we have to make the numbers used instead of selected, right? So how do we sum the numbers? We can just use Lodash for that. Again, logic is not important. This is all application level logic, not UI logic, right? So it's not as important today as it is, in other scenarios. So let's go. Selected sum equal Lodash sum for selected numbers. Okay. That's the sum of selected numbers, or like you can call it sum of selected numbers. Maybe a better name would be sum of selected numbers. Okay, I'm gonna actually call it sum of selected numbers, right? I think it's a better name. Okay, cool. So here's an if statement. This if statement is important. If the sum of selected numbers, right? If the sum of selected numbers equal exactly to the value of that we have in the stars, right? Then the number is not just selected. Actually, the number is not selected at all. If the sum of selected numbers equal the number of stars, the number should be in the used numbers array and not in the selected numbers array, right? Because we're just gonna mark it used, not selected, which means in here, right away, we're gonna unset the selected numbers. Unset the selected numbers, because now we have a correct usage of numbers. So the selected numbers will be empty if this condition is true. Selected numbers will be totally empty if this condition is true, because we got a new number, we got a correct pick of numbers. But we need to place this number, actually we need to place all the selected numbers on the used numbers array, right? We kind of need to transfer the selected numbers array into the used numbers array, because we're clicking multiple. If 3 of them were selected and then number 4, what made the whole selection right, then we need to place all 4 numbers in the used numbers array. So we kind of need to do that. So and also the used numbers array might have existing numbers. So I can't, for example, say something like, okay, used numbers equal selected numbers. I can't do that for multiple reasons. The first reason is used numbers might already have data, and the other reason is this is just a reference. It's not really copying the element. It's just a reference. So there's a big difference between just assigning a reference and copying data, right, in programming in general. So what I need to do is take the selected numbers of stars, the selected numbers here, array of selected numbers, and copy it, append it to a copy of the existing used numbers. And the easiest way to do that is also with spread operator. You spread the used numbers array, and then you spread the selected numbers array in here. And now you have a copy of the old used numbers and the newly selected numbers to be marked as used. And now I can reset the selected numbers array. Also, in this exact condition, I need to redraw stars, right? Because I have a right pick of numbers, I need to redraw the stars. So maybe I just do stars equal and do the exact math random thing that we did before, right? Reinitialize the number of stars. Simplest solution, reinitialize the number of stars. And I think that is testable. This is all the logic that we need, and now we're returning the valuation. So let's go ahead and test. Now, when you start doing loops and set state, just be careful that you might run into trouble, right? Oh, there's a typo, selected numbers. So one quick note, when you start doing loops and set state and like complex logic, you need to be aware that you might run into infinite loops and memory leaks and memory exhaustion, and you might lose the code. So make sure that you save your code, git commit it, put it in the clipboard. Also, make sure that you have DevTools open. If you don't have the DevTools open, you're simply not doing it right. If in an interview, the first thing you did was not to have your DevTools open, I will question your skills. You need to have the DevTools open. Not because you don't want to miss any errors in here, but that's an important thing, right? Because some errors might go unnoticed. You'll be like debugging unnecessarily because there's an error in the DevTools. But also for like cool things, like the DevTools will actually pause. If you have an infinite loop, for example, the DevTools will pause and tell you, it seems like we're going to run out of memory. What are you doing? This is the line that's causing the issue, right? So it has a lot of power, and if you don't have it open, this power is not utilized. So always have your DevTools open. All right, so let's check it out. Let's test. So now that we are doing things, if we click on a number, it should be marked selected or used. And also, if the selection is right, we should draw a new number of stars. Let's test. So if I click on 1, what is my expectations? My expectations is 1 should be selected, not used, which means blue, not green. Nope, it's not working. So we've got an error. Okay, so let's figure out this error. Assignment to a constant variable. All right. That should be an ESLint issue, right? ESLint should tell you, dude, you're doing something bad, right? ESLint should tell you that you can't really do that. You can't define something with const and then reassign it. So this is the value of ESLint. I don't have ESLint in this playground, so I had to deal with this error in the dev tools. Like if I had ESLint, ESLint would tell me, oh, you're doing something wrong here. You are defining variables with const and then trying to reassign their values, and that is assignment to a constant variable. You need let if you are to do this. If you need variables to be changed, you need to define them with let, not const. That's the only place where you need to define them with let. I don't need let here, right? Because I'm not really changing the value of sum of selected numbers, right? I am just, even the whole thing can be skipped by just inlining sum of selected numbers. This is a constant. This is fine as a constant. But these guys needs to be let here because I am changing them and then returning the new values. Okay, let's test now. So you get the value of ESLint, very important, right? Okay, so my expectations. If I pick 2, 2 should be marked as used, which is green. There we go. And I got another number of stars, which is actually interesting. Look at that, we are lucky. We got 2 again, and now we can't pick 2, and we can't pick any other 2 numbers that sum to 2. So this number of stars is invalid now. I can't just pick 2 again, right? Let's try it with a different number. 5, let's pick 5. Good, 4, pick 4. 6, let's pick 2, good, 3, good, 7. We got wrong. Look at that, selection is wrong, is already working because it's computable. I didn't place anything about wrong in the state. I just computed the selection is wrong, and selection is wrong is working. See the power of computing and the power of doing the UI first as a function of your state and then transacting on it? This is becoming easier and easier. Now I don't have unselect here, so I need to redraw the game. What I'm trying to do is trying to show you how we have a problem. We have a big problem. We've got 7, 7. We've got 7. Okay, I can do 7, 6 and 1. We've got another 7. Okay, we can do 7, 5 and 2. We've got 6. I can't do 6. Right? Right here, there is no solution for this particular application state. Right? This is an application state. There's no solution for it. The UI is just honoring your state elements, but now I don't have a solution for this particular number of stars. Why? Because I am just randomly picking a number of stars between 1 and 9 on every correct pick, right? If your selection is correct, I am randomly picking a number of stars between 1 and 9. You get that, right? So how do we fix it? How do we fix it? Well, we can't just randomly pick a number of stars. We need to pick a random number of stars from the available sets of random of stars, right? So if I have 4, if I have 3, 4, 8, and 9, the only available random number of stars that I can pick from are 3, 4, 8, 9, and 7. 4 and 3, right? So 3, 4, 8, 9, and 7. Those are the only 5 random numbers that I can draw at that point, right? You get that? Available random number of stars. Not all the random numbers of stars from 1 to 9 are available. You have to remove what's already not available, like 6. 6 is not available. 5 is not available. Only 3, 4, 8, 9, and 7. Those are the only available 5 options in this particular UI. Now, this is a famous math problem, so we're not going to analyze the function. So I'll just paste it in here at the end of the whole thing. So this is computations for picking a number from an array of numbers, and the maximum sum is what you need, right? This whole thing, I copied it somewhere and just improved it a little bit, but this is like double loops to go over all the permutations, of the available numbers and give you the candidates that you can use. Don't worry about that. Again, math science. So you would consult a math scientist for this function. It's not part of your UI logic. But once we have that, now instead of doing random selection of stars in here, we can use this new function to only draw the available number of stars. Now, to make it available number of stars, you kind of need to know the difference. You need to give it an array. So this takes in an array of available numbers, which is basically you give it 3, 4, 8, and 9, and then you give it the max sum to be 9, and it will give you back the 5 numbers I just said, right? The 3, 4, 8, 9, and 7. So you need to give it the array of your available numbers, right? Now, unfortunately, we don't have the array of available numbers, right? We have the array of all the numbers, which is basically range between, where is that array? This is the array of all the numbers, right? This is the array of all the numbers. And we have the array of used numbers in here, right? And I need to kind of like subtract them from each other, right? I need to subtract the used numbers from all the numbers and then pass that array, because once I subtract them from each other, those are my available number, and pass that array to my random sum function. So the range that I need here is I need random sum, and in here I need to pass the available numbers, and the max is 9. The max is constant 9, right? So we need to compute the available numbers. Now, to compute the available numbers, we should probably make this into a named variable, because now it's gonna be part of your application logic. You should probably make it into a named variable. So let's call it all numbers. All numbers. This is the array of all numbers. All numbers array. Now, all numbers can be defined anywhere. We can define it like right here. It doesn't matter. Const all numbers. Const all numbers is this exact range. This is all numbers. This all numbers can actually be also right here, and it will just work. It doesn't have to be, doesn't need to close over anything, right? But I'm just gonna keep it here for consistency. All numbers. All right, so we just need the available numbers is the difference between all numbers and used numbers, and we can also use Lodash for that. So let's do difference. Lodash has this difference method, and you pass it all numbers, and you pass it used numbers, and it will do the difference. And it'll pass it used numbers, it will do the difference, and now you get a random number of stars that's basically within the available set. It's not just a random number of stars. All right, so this is something we can test. Again, make sure your code is safe in case you're gonna run into a loop, because look at that, we have double nested loops in here. You might run into infinite loops if this is wrong. So be prepared for that. Have the DevTools open, right? I'm closing the DevTools because I'm out of space in here, and the playground is weird when you don't have a lot of space, but you need to have the DevTools open. All right, let's test. Our test is basically the generated number of stars should always have a solution. So I'm just gonna play. We've got 6, 7, let's play. 5, sure. I've got another 5. I can do that, 3 and 2. How about, what is that, 9? Sure, 9. How about 6? 6. How about 8? 8. Look at that. It looks like it's working. When I click 8, the random number of stars should be 4, because that's the only available solution at that point. So let's test. There you go. 4. So this math science here is valid, and it's working. All right, so we're close to being really done from this game, except that there are bugs, right? So if you're interviewing for a QA job, I would tell you, can you try and find a bug now? So, stress test this game and see if you can find a bug. So you can reuse a number. So check it out. We have 9 numbers. That's not a good. 4 numbers, right? If you click 2 twice, I just reused the number. That's not valid, right? So that's not good. Like, I can click this because I have 9 numbers. I can click 9 numbers and it will be valid. That's bad, right? And that's a very subtle bug, right? Now, what do you do when your QA team comes to you with this bug? What do you do? That's an interview question. So I just found a bug for you. What do you do when the QA team comes back to you with a bug in your code? What do you do? And the magical answer in the interview is write an automated test to reproduce it with code, right? Because the fix is easy. The fix is a very small change in the code. However, this is a golden chance for you to enforce the testability of your code, because you've shipped code with a bug, not knowing about this bug, and some other person discovered the bug. So your code, you were not aware of that. So what you need to do is write a test that reproduce the bug before you fix it. And once you see that test read and working, you go fix it and make sure your test is green. This way, this particular UI testing scenario will be forever tested. When you start changing the game over and over and over and over, this particular scenario will be forever tested. So you need to write an automated test for that. Every time you find a bug, you should write an automated test for that. And you should really write an automated test before you're designing your component. And we might have prevented this bug from happening if we were testing first, right? But we're not testing this particular example, and we found a bug. This is your clue that you should immediately write a test for that. Now, we don't have a time for test. I'm going to show you a few more concepts, but the fix here is easy, right? This is the problem. You can't just select a number. You can only select a number if the number is not selected, right? So you really kind of have to have another if statement here that says if the number is not selected, which is easy, so let's do it. If the number is not selected, if selected numbers, the index of, again, application logic, math, number is greater than 0, that means the number is already selected, right? That means the number is already selected. You can't do that. So in that case, number is selected, right? You need the else really here. In the else, number is not selected, you can select it, right? No, it's not actually working. Oh, greater than or equal to 0. Okay, so how about now? Is this bug gone? Can I select 1, 1, 1, 1? No, nope, we're good. We're good. Bug, ship it, right? We've got 6. Can I do 3 twice? Nope, it's golden. All right. Okay. So, what else can we do? How about unselect a number? If you commit to a solution that is bad, give me a chance to undo it and select something better, right? Give me a chance to undo this. I got 5. Oh, I meant 4. I need to undo this. And that's easy because what we just did here is also a case for it. If the number is selected and you want to click it again, what do you want to do? Instead of counting it as selected, maybe remove it from the selected numbers, right? If I click the 5 again, the one that is selected, because 5 is selected, it's just displayed wrong because the selection is wrong. So 5 is selected. So if I click on a selected number, how about we remove it from the selected numbers? Yep, let's unselect. How do we do that? So if we're in an interview, you would totally need to come with that on your own at this point. Even if you don't understand half of the things I did, you should be able to unselect a number by removing it from an array. How do you remove a number from an array and like come up with another array that doesn't have that number, right? Because we've got selected numbers and we need to remove one number of it and have a new array that doesn't have that number. You can split the array, or you can just use the filter method. There are 3 magical methods that you should master. We already used map. You also need to master reduce and filter. These are 3 really good methods to always have in mind, right? Filter is the one that we need here. We can do selected numbers equal selected numbers dot filter the number that was just clicked. So if you return true from here, the number would be selected. If you return false, the number would be filtered. So this is a selected number here, and the condition that you need is selected number does not equal number. If the selected number does not equal the number, then I need to filter this number in. I need to have it in the selected numbers array. Let's go ahead and test that. So I'm going to select 4, 5. I'm going to undo it. There we go. And now select 3. So one question, the importance of the setState callback function. Why did I do this, right? And I'll try to, let's go to the React.js library documentation. I think they have, an example about a button, right? Hopefully we'll get that. All right, here is a good example. So I'm going to take that to the playground and work this example. Okay, so you kind of need to render it, huh? You don't need to import. You can just React DOM. So this is an example. I'm going to render it to mount node. Very simple button that will, count the numbers of clicked items, right? Okay, here's your session. All right, so I'm gonna upgrade this from an inline handler to an actual handler called handle click, and put handle click on a constant here. Handle click is a function that will do exactly that. We don't need an arrow function anymore. We'll do exactly that. So this will be the same. It's still clicking and life is good, right? Refresh. So in an interview, if we're doing this example, I would ask you this question. What would happen if I repeated this line? What would happen if I repeated this set count line inside the handle click method? If I click the button, will it increment the counter by 1 or 2? Very important interview question. Go. You can't test it. Will it increment the counter by 1 or 2? Of course, you're kind of guessing the answer, right? It will increment the counter by 1, not 2. And the reason is this is async and this is async. And because it's async, it's not really going to change the count at all, right? This is async. You're just reading the count synchronously, and then because it's async, you're falling back in here and you're reading the count synchronously. So you're basically doing that same operation twice, and that's why it's not counting by 2, right? It's just counting by 1. The fix for that is to use the updater function. If you use the updater function, then you're no longer reading the count at this point. You can read the count from the previous state. So this is the count that we're incrementing, and in here I am reading it from the previous state. So now when you click, it's not working. This is previous. Oh, the previous state is count. It's not an object. So you read it from the previous state. You can actually simplify this whole thing. You can just read it from the previous state. By using the updater function, I am not reading the count here. I am reading it when the set count is to be executed, right? And now it will increment by 2 times. So that's an important question, right? You need to understand. You need to always remember that React batch things for performance. And that's why all the updater functions are asynchronous. And that's why you need to use the callback version of setState when you need to update the state. Reset game when it's finished. Maybe we can actually do that. So how do we reset the game? If the game is done, when is the game done? The game is done when I don't have any more available numbers, right? When all the numbers are used numbers, right? That's when the game is done. The game is done when all the numbers are used numbers, right? So maybe we can actually compute this. This is a computable thing. This is not something I need to put on the state. I can compute it right here. I can say game is done when the used numbers, which is state.usedNumbers, dot length, the length of this array, equal the length of the all numbers array, right? If this is correct, if this is a true Boolean, the game is done, right? And if the game is done, I could do something differently. So in here, maybe, I don't know, right somewhere in the UI, you can say if the game is done, game is done. If the game is done, then render a play again button. How about we do that? Just and would be enough. Render a play again button. Let me do that. Render a button to play again. And I only want to render this button when the game is done, not all the time. So let's try to get the game done. 3, 5, 9, 8, 7, 6, 2, 1. Play again. Check it out. Play again. It's ugly, but it's there, right? Let's put it in a div. It's just the styling of the thing is in here. Actually, I'm not sure the div is going to actually do it. Well, we can actually do it somewhere else. Like we can do it in place of the stars, or like in place of this whole thing, really, right? Like I can say something like, you know what? If the game is done, render a button, right? If the game is done, render a button to play again. Otherwise, render this whole thing, right? That's valid, by the way. Otherwise, render the whole left and right columns, the whole thing, right? Now you need to make it a little bit better, like this. Actually, I think the better syntax is to have it this way. So if the game is done, render a play again button. Otherwise, we need to render 2 divs, right? Left and right. We need to render this whole thing. Now, you can't render two adjacent element in JSX, right? You can't render two adjacent element in JSX. You have to render always a single element. So you can place these two divs in a single element, like in another div element. But if you want to do this without introducing a new div to your UI, you can just render a React.fragment like this. React.fragment and React.fragment. This empty tag means React.fragment, right? And a fragment is basically an element that can surround your two elements and have them as a single entity without introducing a new div. So this should work, right? If the game is done, the whole game is going to go away and you will get a play again button, right? So let's test that. We've got 5, we've got 9, we've got 5 again, we've got 2, 8, 7, nope, 6 and 3, 3 and 7, and check it out, play again. The whole game was unmounted. This whole two divs were unmounted, and now we mount a new element. Play again. All right, so how do you play again? Well, on click, you really should do a handler here. Reset game would be a good name. On click, reset game. Don't inline it. How do we do it? Well, we can do reset game is a function, so we put it in a constant. This is a function that basically receives nothing, right? And to reset the game, what do you need to do? Well, you really just need to reset the state, right? If you reset all three elements on the state, right? If you reset all three elements on the state, you are resetting the game. Because if you have new used numbers, you have new selected numbers, you're basically resetting the game, right? There are no complexities about resetting this particular game because we don't have any side effects. Like this application does not have any side effects, which is a big win. What do I mean by side effects? It does not have any timers. It does not subscribe to data. It does not change the DOM manually. Everything is done through React, and because of that, we have a big win. We don't have side effects. We don't have to worry about side effects, right? Because if we have side effects, then when we reset the game, we also need to reset the side effects. We need to make sure that the side effects are not going to leak in memory. And that's a good exercise, next step exercise for this game. So I'm going to leave it for you as a homework. How to reset the game if you have side effects. And we can easily introduce side effects. The hook for that is useEffect. And effect is for side effects. You know, if you want to introduce a side effect, there is a way for you to do that. useEffect. So one example of a side effect you can do is timers. Make this game, this is a homework, make this game timed. Give the user 10 seconds or 15 seconds to finish the game. And if they don't finish it in 15 seconds, game over, right? That would make the game interesting, right? Give the user 15 seconds. Maybe 15 is too much. I don't know. Like, find the number that will make it interesting. And if they don't finish it in that, reset the game. By creating a timer in your game app, you're introducing a side effect. And that would make resetting the game a little bit more challenging. But it's not too bad. It's actually easy. But since we don't have side effects, all we need to do to reset the game is set state and give it the initial state object that we started with. And that will reset the game. Just give me the same initial state object that we reset with. Random number of stars and empty used array of selected numbers and used numbers. Let's test. 4, 7, another 7, 8, 9, 5, 3. And now we test. And boom, we have a new game.